In the midst of the American Civil War, a young surgeon took the blow to his arms and had to undergo an amputation. This man was the protagonist of Silas Weir Mitchell's acclaimed story, The Case of George Dedlow. Soon after his amputation, Dedlow began feeling lifelike sensations of pain and itches in his lost arm. Feeling sensations in a limb that isn't even there? What in the bizarre chronicles of the human mind is this? Well, say hello to the brain, where lies some of our life's greatest secrets. Today, about 98% of amputees report phantom limb sensations, where patients feel the ghostly presence of an amputated limb. To understand phantom sensations, we first have to understand how we even feel sensations. Every time we get hurt and suffer from an acute pain, our nerves carry signals from touch receptors in the skin all the way to the brain. The thalamus receives these signals and passes it on to the cerebral cortex, which interprets the sensation as pain. Our brains possess the remarkable ability to map parts of the body, with specific regions in the sensory cortex handling signals from specific organs. The area assigned to each body part correlates to the number of signals it receives from that body part, a pictorial representation of which is commonly referred to as motor or sensory homunculi. When the intact physical hand is introduced to pain, pressure, or heat, the sensation registers in the cortical area of the somatosensory cortex known as the homuncular hand. Conversely, when the homuncular hand is stimulated using electrodes, the same sensation is felt as if it's originating the physical hand. Scientists have hypothesized several theories which explain phantom sensations. The mappings of the body parts continue to remain in the cortex even if the corresponding limb is no longer present. Nerve endings at the site of the amputation get inflamed, and the resulting neuromas are hypersensitive. Even the slightest of stimuli can trigger a misfire of signals, confusing and tricking the brain to believe that these signals are coming from a non-existent limb. It was also observed that a patient who lost an arm felt strokes in his phantom fingers when his cheek was being stroked. This would suggest that somehow the hand area on the map was activated when signals reached the face area. But how is that even possible? Well, as it turns out, the cortical area previously corresponding to the arm was not dormant as one might assume after the amputation, but instead responded to stimulation of the face. Because the homuncular face and hand are adjacent to one another in the somatosensory cortex, when neural region belonging to the homuncular hand sat unused, the homuncular face began to encroach upon it to make use of the idle region. And there it is. Now signals from the face travel to both the homuncular hand as well as the face. Phantom sensations today are treated with a combination of pain relievers, physical and psychological therapy. New advancements in this field could potentially answer biology's biggest mystery: how the brain actually works.